I hear it all the time. The mere mention of design of steel structures is enough to send a shiver down the spine of even the most dedicated engineering student. You might be in your second or third year, hitting what feels like this massive, confusing brick wall. But today, we're going to completely transform this daunting subject into a clear, easy to navigate roadmap for your competitive exams. We're going to build this from the ground up, starting right at zero, so you can stop stressing and start mastering.
Okay, here's our game plan for today's explainer. 1. Steel structures exam weightage. 2. The essential structural tools. 3. Mastering steel connections. 4. Key structural members. And finally, 5. Course schedule and details.
All right, let's jump straight into section 1, steel structures exam weightage.
So why are we even talking about this? Well, just look at the numbers across these exams. If you're tackling the GATE exam, you're looking at a solid 5 to 6 marks. For assistant and junior engineer exams, your AE and JE, it's around 10 marks, which is roughly 10% of a standard paper. But here is the real kicker. For the ESE prelims, we are talking a staggering 25 to 30 marks. Mastering this stuff, it gives you a massive competitive advantage. It is literally the difference between just blending in with the crowd and standing out as a top-tier candidate. And it gets even better. For the ESE mains, that weightage balloons up to a massive 50 to 60 marks. I really want to drive this home right now. If you put in the time to master steel structures, you are practically engineering your own exam success. The return on investment for your study time here is just absolutely phenomenal.
Moving right along to Section 2, the essential structural tools.
Listen up, because this is absolutely crucial. IS Code 8000-2007 is, without a doubt, our holy book for this subject. Just like you rely heavily on IS 456 for concrete, this 2007 code is your ultimate grunth for limit state design in steel. Forget the older versions and don't mix it up with load-specific codes. Just make sure you have a hard copy or a PDF of this specific code ready by your side at all times. And right next to that code book, you've got to have your steel table. Think of it as your essential companion for quickly grabbing structural specs. Whether you're dealing with angle and channel sections, I-beams, or T-bars, the steel table gives you immediate, accurate access to the radius of gyration, moment of inertia, and cross-section area. You absolutely do not want to be guessing these numbers during an exam or on a job site. You want to flip open that table and look them up swiftly like a pro.
Okay, let's dive into Section 3, mastering steel connections.
Let's play a little imagination game. Step directly into the shoes of a lead engineer for a second. Imagine you're managing this massive, real-world project, like building a giant football stadium. Which connection type are you going to use? Are you going to rely on traditional rivets, modern bolts, or heavy-duty welds to hold thousands of tons of steel together up in the air? Well, in modern construction, it usually comes down to two main choices. Bolted connections are fantastic because they're temporary. If your structure only needs to stand for, say, 5 years, you can literally just unbolt it, dismantle the whole thing, and reuse that steel later without destroying it. On the flip side, welded connections are permanent. They offer superior strength because you are quite literally melting metals together to form a bond. But keep in mind, that requires highly skilled labor and specific gear. Oh, and those older riveted connections? Yeah, they've largely been replaced by bolts today. So your choice really boils down to the exact lifespan and purpose of your structure.
And guys, this choice exposes a huge real-world financial danger: poor engineering. Just look at the cost of over-designing. We're talking of 15 lakhs versus 30 lakhs. If you blindly guess the number of bolts you need, like throwing in 6 when 3 would work perfectly, you just needlessly doubled the cost of that connection. Multiply that over an entire structure with thousands of joints and boom, your uneconomical design just wasted millions. So how do we fix that? Calculating the exact optimum number of bolts actually just takes 3 logical steps. Step 1, identify your total joint load. Let's say a truss joint is taking 100 kilonewtons of force. Step 2, find the single bolt strength by checking its shearing, bearing, and tension, and grab the lowest value. Let's assume one bolt can safely handle 20 kilonewtons. Step 3, just do the math. 100 divided by 20 equals exactly 5 bolts. No guessing, no wasted money, just pure, economical, optimum engineering.
All right, let's look at Section 4, key structural members.
Now, one standalone topic you absolutely have to wrap your head around is plastic analysis. This is a theoretical structural concept used to calculate the ultimate collapse load of a structure. It actually functions a bit differently from the rest of the physical steel syllabus. It leans more into pure structural analysis, but it is incredibly vital for understanding the exact point at which a structure will, theoretically, fail entirely. And as for our core physical topics, here's the breakdown of the rest of your roadmap. We dive into compression members, where we heavily study columns, struts, and the intricate patterns of leasing and battening. Then tension members, which involves angles, plates, and really fascinating theoretical phenomena like shear lag. And finally, beams and girders, where we look closely at flexure, deflection limits set by the IS code, and why web stiffeners are an absolute must. Which brings us to our final part, Section 5, Course Schedule and Details. So here is your clear, straightforward study timeline. Today, the window is officially open to begin. Your job is to make a daily commitment to our 7 p.m. YouTube classes. Be there, stay disciplined, and put in the reps. But I want you to notice that crucial August 1st marker. That is when our paid batch G officially starts. And more importantly, that is when the price hike happens. But hey, you don't actually have to pay full price if you act right now. By using the discount code Y501, the batch G price drops from 12,000 INR all the way down to roughly 9,000 INR. We're intentionally leaving this window open for students who want to be proactive and enroll before that August 1st hike. It's simply the most economical investment you can make in your exam prep today. So I have to ask, are you ready to stop fearing steel structures and start actually engineering your future? The roadmap is laid out, your tools are ready, and the schedule is locked in. Challenge yourself to take immediate action and join these upcoming classes. Because really, the next time you walk into a massive, towering stadium, ask yourself, do you want to just be a spectator? Or do you want to be the engineer who knows exactly how the whole thing is holding together?